Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today we are just trying to see a topic, and that is law of large numbers. Now this is one more topic which just come under that section of basically central limit theorem, right? Previously what we were doing, we were just doing that central limit theorem, and under that section this one law is there, that is law for large number that comes. Now today we are just going to see that basically what is this law, and after that what I'm just going to tell you is that I'm just going to take one example, take one question that basically consists of 4 parts. So we are just going to solve 2 parts in this particular video and the rest 2 parts in the next video, right? So this is the procedure which we are just going to follow for doing this thing, right? So I would just not waste a lot of time here while talking, and let's get started and do the things right here. Fine. So my first thing which I would just discuss here is the law of large number. Okay, I will just write the heading also. So yeah, law of its large numbers. So it's large, and then here it's numbers. Fine. So we are just going to see that basically what does this law of large number actually means, right? So I would just write the statement which is there for this law of large numbers, and from that only we will just get an idea that basically what this law of large number, and like what we can just conclude from this, what we can understand from this, right? We are just going to learn that thing, right? So let me just write here the law of large number. I'm just writing the short form for numbers, okay? The law of large numbers says, and just let me go down so that I can just like write a little bit of neater handwriting, okay? The law of large numbers says that if you take samples of larger and larger size, okay? The law of large numbers says that if you take samples of larger and larger size from any population, okay, from, and just let me go more down, from any population. So I'm even writing the short form of population also, okay? So it's population basically. Then the mean, what does the mean? We just give it a like denotation of s a bar, right? Is then a line number, we just call it as bar. So then the mean x bar of the sample tends to be closer to mu, right? So this is the statement for the law of large numbers, that the law of large numbers says that if you take samples of larger and larger size from any population, then the mean x bar of the sample tends to be closer to mu, right? So this is a sentence which is there for the law of large numbers. Now, what I just said, that we firstly will be seeing that what is the law for that large numbers, and then we will be moving towards the question for today, right? But before that I would just ask you one thing, and even just tell you one thing, that I hope that just you are all like writing the things with me, right? Because I'm just not writing this for myself, I'm just writing these things right here so that you can just take a proper notes of each and everything whatever I am telling. If I'm only and only speaking, then you will not get that proper idea that what I am just telling, like trying to tell you, trying to like make you understand, right? But if I just write something, then you will just get a fair idea that what I am trying to say, and you can just make your proper notes itself, okay, right? So that is why I'm just writing it. So I hope you all must be writing with me, and if you have not started writing yet, so just go and open your notebooks and start writing what you all are waiting for, right? So let me just repeat the statement once more. The law of large numbers says that if you take samples of larger and larger size from any population, then the mean x bar of the sample tends to be closer to mu, right? So this is the you can say the statement for the law of large numbers. Now here is the question for the day, and my question says that a study involving stress is done on a college campus among the students. The stress score follow the uniform distribution, with the lowest test score equal to 1 and the highest equal to 5. Okay, using the sample of 75 students, find first the probability that the mean stress score for the 75 student is less than 2. Okay, and B, the 90th percentile for the mean stress score for the 75 students, right? So here what I need to do is that I need to find these two things, firstly A and then B, right? Let me just take a particular highlighter, so I can just like highlight the important things whatever I just here. Okay, so I just thought that important is the stress score follow the uniform distribution with the lowest test score. So my lowest test score is equal to 1, right? And this one, and my highest is equal to 5, right? This thing, fine. So this is the, and what is the sample? Sample size is total 75. So these are the three important points from my question what I am just having right now. Okay. Now what I need to do is that I need to solve this question. Just let me take a pen and I would just start solving the question. Fine. Now, here firstly, what are the common things which I can just write while seeing this sentence, the first question, okay? Leave these subparts, okay? Leave them, right? If I just leave these subparts, then from this question which I'm just getting here, what are the things which I can just include here, right? Let's quickly just see that thing firstly. So I would just write here as solution and just, yeah. Fine. So my solution is firstly I would just take a variable x. Okay. So I would just take a variable x and I would just say let x is equal to 1 stress score. Okay, 1 stress score. And if you're just following my videos from the very starting of the statistics playlist, then you will not be needing me for this question, right? You will be able to solve this question on your own only, right? You will not like require me to solve the question and make you understand. You will do that thing on your own. So I would just suggest that do see all the things from the starting only, right? Don't just skip and see the things here. Fine. Okay. I was given that x is equal, I just let that x is equal to 1 stress score. I am giving the value of n, right? I am having the value for the sample size, that is 75, right? Now what next I have? Okay. So here I can just write since the individual stress score, and yeah, I need to just go down, I guess. Yeah, stress, I'm just writing it from here. Stress score follow a uniform distribution. Okay, follow a uniform distribution. This is the thing which is written in question. I'm just not writing anything new here. Okay, so I just wrote it that since the individual stress score follow a uniform distribution, and yeah, here I would just include that x approximate equal to u, and here in the bracket I would just write 1 comma 5. So what were 1 and 5? I just highlighted those things here. Just let me take my cursor here. I just highlighted those things, that the lowest test score is equal to 1 and the highest is equal to 5. So that thing only I just wrote here, x approximate 1 comma 5, right? And what else I wrote, n is equal to 75. So we were given that using the sample of 75 students. What else I was having? Yeah, I just wrote the sentence that since the individual stress score follow a uniform distribution, right? So we are just given this thing also in the question. So you can just check out the second line of this question, that stress score follow the uniform distribution, right? So all of the things are just given in the question itself, right? So I'm just trying to like explain you the solution, that how you should proceed. Okay, and here I would just write, so now a would be having the value as 1 and b would be having the value as 5. So I would just write where a is equal to 1 comma b is equal to 5, right? So a and b values are given in this bracket. Fine. So from here, what are the things that I can just calculate, right? So firstly, I can just calculate the mu x, right? So for calculating the mu x, the formula was a plus b divided by 2, right? So I am having the value for a. Even I am having, just let me erase it for a while and just let me write in a clearer handwriting so that you can just see that, right? Okay. So the formula for calculating that was a plus b by 2, right? So I am having the value for a and I am having the value for b itself. So I would just quickly put those values. So it's 1 plus 5 divided by 2. So then 6 divided by 2, and that is 3, right? So from here I can just get the value for the mu x. Fine. What else I can just get now? I can even calculate the sigma x. Okay, standard deviation for my value from x. Now what is the formula for that? We had already seen. So it was under root b minus a whole square divided by 12. Yes, this was the formula, right? Now I'm just going to put the values and basically I'm just going to find the final answer. So it's 5 minus 1. Okay, so value for b is 5 and the value for A is 1, right? And I would just write here under like 12. So when you're just going to compute and find the final answer, it would be 1.15. Yeah, you can just do that thing on your own. Fine. Okay. So this was the common thing which I have just done here for this particular question, right? I have not taken any particular part, right? Till now I have not chosen a part that I'm going to follow the part A or part B or anything like that. So I just computed the things what I can just find from the information that I am given in the question. Okay. So in that I was just like given the lowest score, the highest score. So here you can just take a note, take a point that why I'm just doing this. So from here, if you just get the some question like this, in which you are just like told that the lowest score is this, highest score is this, if they do not tell you the things directly, if they are telling you the things indirectly, so how you are going to proceed that question, okay? How you are just going to solve that question. So that thing I have just explained you right now, okay? Fine. Let me go down here. So that mu x and sigma x is now computed. Now I can just like take the things. So I would just write here from for my problem 1 and my problem 2, let x bar, I would just write here as capital X, okay? Let x bar is equal to the mean stress score for the 75 students. So I had just taken a particular variable and I had just like written that let x bar is equal to the mean stress score for the 75 students, fine. And what else I can just write? So x bar is equal to n, and here I can just write 3 comma 1.15 upon under root of 75. So these are the values which I got. 3 value is for my mu x, which I just computed that side, right? This 1.15 is from my sigma x, which I computed, and this is my under root of n. So on n is my total sample. So in that case, I was having the n as 75, right? So from this, we can just conclude all of these things. And yeah, I just mentioned the thing that how did I just put the values, fine. Now let's quickly move towards the very first question of this part, right? So my first question says to me to find the probability that the mean stress score for the 75 students is less than 2. Okay, I need to find that the mean stress score for 75 students is less than 2. Okay, I need to solve this question. Okay, so I would just write here as problem 1 and let's begin. So I would just write it that what I need to find the probability. Okay, I would just write P outside. Probability of x bar less than 2. Fine, I need to do that. So before just doing that, I would just make the graph for it, okay? So I would just make the graph here itself. I had to go like very down and I would just take one of any color. Let me just take any highlighter. So that would be more easier, right? So my graph would something go like this, okay? We know that the graph for this distribution, like we make the graph for the distribution like this only, right? So I had just done that thing only. I just made this graph and let me just take a color so that now I can just highlight the things. So my x line, and from here it is that curve. I know that it is looking very bad, but we need to manage in this only right now. I would take the color and okay, fine. So what is this? This is my, here I would just write as 2, this is 3 and let's say this is 4. Okay, let me just go down because I just think that because of the image that is not properly visible, right? Now what does this graph basically shows us, right? So this graph basically shows us the probability, right? The probability which we need to find. It shows us that thing. So I would just put the arrow sign here and here I would just write probability of x bar is less than 2. Right, so here I just made that graph to show this thing, right? We can just like take the things visually also while doing these types of questions, fine. So let's say I just wrote here probability probability of x bar is less than 2 is equal to 0. So this is the probability that would come. Now how to compute that probability, I'm not just gonna tell this thing right now because we have already done several questions on that. Okay, now I would just not waste time while repeating the same things. So if you just want to go and see that basically how to find the probability, so you can pick any of the questions. Okay, you can pick any of the questions from my videos and you can just watch. So basically almost in 90 to 95% of the videos for the questions we had already solved how to find the probability. Fine. Next, what I can just find the normal CDF, right? I can just find the normal CDF from the data which I am just given here, right? So I would just write normal CDF and then I would just put the bracket. Okay, just one second. Fine, I would put the bracket here. Fine. Now here I can just write the values which I am just having here, that is 3 comma 1 point that was 1.15, right? That the value which we have computed for the standard deviation, right? That was 1.15. This was in, and yeah, what was so these were the mean and other the values, right? So this is the thing that we can just compute it from here. So what can I just conclude here? I can conclude, so the probability, okay, I will just write the full spelling only. So the probability that the mean stress score, that the mean stress score is less than 2. Oh, I'm just so sorry for that. Just one second, yeah. And just let me go down. Is less than 2. So the probability that the mean stress score is less than 2 is about 0. Fine. So here I just finished up my first question, that was find the probability that the mean stress score for the 75 students is less than 2, right? That question I have just solved. Now moving towards the second question, we'll be seeing the second, third and fourth, these three parts of this question in the next video, right? So now here I hope that my main motive was to explain you. My main motive was not that I will tell you how to find the probability. No, because we already know all that things. My main motive was to tell you that using these three lines, how you can just compute, how you can just like take and find out that what are the things which you can just take it from here, right? Let's say that x value for n, mu x, sigma x, right? So these are the things which you can just take it from here, right? So I hope you just got the idea to how to just solve these types of questions, and even we are just left with 3 more parts in this question, so I would be covering that in the next video, right? So this is all for this video. Till then, thank you and bye bye.